So team, welcome to ISTQB Foundation Level Certification Training Day 2. We have completed one orientation followed by day 1 yesterday. So if anybody is new joining for the first day today, strongly recommend to go watch the orientation first, which is available on our website itlearn.com as well as in YouTube and all social networking forums. Followed by yesterday we started with the first topic. So there are about 6 chapters that we have to deal in this in the course of examination for the foundation level, and we started with the first one. So you can even visit that video as well in the itlearn website. And followed by we are in day 2. So anybody is new today? Just to know the count basically. Not really, that's good. So let's go back and see what we have dealt yesterday. So yesterday we dealt with only 2 important things. One is the why testing is important. That's the first thing. The second thing, what are the reasons for the failures, right? So we looked at these 2 aspects, of course, with a good amount of examples on what are the different defects that can happen in different industry types and why they are important. So going back and looking at very generic examples on the industry-wide is very interesting, but this is more of an examination point of view. So we have to stick to some of the definitions, how exactly ISTQB expect you to define. Okay, so sometimes we have to come back to the document and stick to those definitions, and sometimes we'll go back and look at some of the generic examples as per the industry and everything. Okay, so let's look at some of these important terminologies which are very important from a software testing perspective. We kind of discussed the primary job of software testers. If you ask, it is your responsibility to identify people will say different things. Some people will say identify bugs in the system. Somebody will say identify defects in the software. Somebody will say errors. And somebody might say faults in the software. Right? There are different terminologies that you get to hear. So let's try to understand what these are and which one leads to what, etc. Okay, but definitely it is something, all this is actually going to create a problem to the software so that it is not going to work the expected way. So it needs to be eliminated, all of these. But who will eliminate all of this is a different thing. Let's try to understand the definitions perspective first, and then we'll see what is each one of them. So typically, generally, if you think about error, right? So error, you can simply synonym it as a mistake. Somebody does a mistake, and that will actually create an incorrect result. So it's basically a human action that produces an incorrect result. That's a simple definition that we can give it for error or a mistake. Now, who does it? It could be your project manager, like we looked at. This is a typical flow, right? So first you will get requirements for your software, and who is responsible to take care of it is your PM. Some companies, product companies, call it as TPM, technical program manager. Some companies call it as a program manager. Some companies call it as a project manager. So he is responsible for getting it as a requirement or user story in today's agile world. So requirement or user story is your first thing. That leads to the second phase of the life cycle is typically the design. So then comes a designing phase. Who does the design? In good companies, product-based companies, there will be a designer team. Specific design team will be there who is responsible for doing that. If not, one of your senior dev lead dev lead will be responsible for doing it. So that's the second phase, and within the design there are two things will happen. One is the high level design, HLD is what we call it as. A low level design at each component level is LLD. If you want more specific example, let's say you want to build a very simple system which takes let's say different types of inputs, input files, okay, input files, and then let's say it will simply compress something like WinZip, let's assume. It will compress and give you an output in the form of, let's say, .zip. That's the system that you want to build. So this you can consider it to be high level. This is the high level design. Very simple, takes a different input files, .txt, .pdf, .document, .excel file, XLSX file, etc., etc., compress it, give the output as .zip. So this is HLD, high level design. In low level design, what people will try to do is they will explain this compression feature at very unit level. How does it takes care of text files? How does it takes care of Excel files? How does it takes care of PDF files? How it takes care of documents files? So every unit they will explain in detail. Each component they will explain in detail in low level design, how it's going to happen. So that is the difference between high level and low level design. So who is going to do that? Your dev lead is going to do that. Okay, once the design is approved, then they will go into coding phase. Coding phase, or you can call it as a development phase. Development phase. Then comes to, they are responsible for coding plus code reviews. One person, one developer has done a code, other developer has to review. Similarly, like that, everybody will review each other code, and they are responsible for unit testing. They have to do unit testing as well. So that is what is the meaning of coding phase. So then comes the testing phase. So then comes the testing phase. Testing, or you can call it as stabilization phase, where you actually stabilize a product by eliminating the, I don't know what to use right now because we are understanding the definitions, but I can safely use by eliminating defects. Okay, so you are going to stabilize or test the product for eliminating the issues. So that is how typically it will go. Now, what is the definition that we're talking about? Error. Error means any human mistake. It's basically a human mistake that will result in incorrect result. Now, where does the error can happen? Error can happen anywhere. Error can happen here by the PM. Error can happen here by the dev lead in terms of designing. Error can happen during the coding, right? If you are doing an automation development as a tester, you might also do errors. Or even if you're doing a manual testing, you might be actually testing something incorrectly. So error can happen anywhere, and we are all humans, and we do mistakes. So that is what is meaning of error. Error is basically a mistake, a human action that produces an incorrect result. And there is another factor that we talk about, the risk, a factor that could result in future negative consequences. So generally when we talk about a risk, it's a factor that can result in future negative consequences. For example, what is the risk if somebody does, let's say, Excel file comparison wrong? The developer who is actually working on this component, while compressing the Excel files, he did a mistake. So what can be the risk of that? So that definitely depends on how much usage of these and how many clients are going to use this, how many users are going to use this, and how badly it will affect our product. So the risk will be high depending on the complexity of it. So that is what is risk. It's basically a factor that could result in future negative consequences, usually expressed as impact and likelihood. So we generally say there is a high likelihood of risk or low likelihood of risk, or there is a medium likelihood of risk is what we generally call it as. Then comes a defect, and these are the synonyms. Defect can be represented as a bug or a fault. A flaw in a component or a system that can cause the component or system to fail to perform its required function. A flaw in a component or a system which will cause the system to fail to perform its required function. For example, this is the expected functionality of this compressing software, and there is a problem in handling the files. Let us assume if the file size is more than, just an example, if the file size goes let's say beyond 10 GB, there is a problem that's being not handled, let's say. So what it will do when I upload the files which are more than 10 GB and try to do a compression, I'm not going to get the expected output. So that is what is actually a defect in my system. And the synonym for it, you can even call it as a bug, or you can call it as a fault. A defect, if encountered during execution, may cause the failure of the component or system. So typically, there could be different type of defects. One type of defect will make your entire system down. One type of defect that's more like a functional defect. One type of system or defect might make your compression very, very, very slow, a performance related issue. It does not even handle those type of files which you're trying to do. So design defect. So there could be different types of defects you will see. Some of them related to functional, some of them related to performance, some of them related to the security. If you're working with a web applications and if you're dealing with the different user types, so there could be different issues that can come up. So that's basically what you call it as a defect. A failure, basically a deviation of the component or system from its expected delivery, service or result. So when we generally say this system is failed, if it is deviating from its expected delivery. Suppose a car has to, like, let's not get into there. Let's say software has to perform certain functionality and the expected delivery is to come back with this .zip as an output, and if it is for some reason it's not coming, that is what again you can say the system is failed. It's not meeting its expected delivery. So we can say that's the failure of the system. So typically this is the flow. Somebody does a mistake. You can see how they happen is somebody does a mistake while doing their activity. It could be the program manager while writing the requirement, could be to the designer while designing the system, it could be the developer who is actually developing the system, does an error, basically a mistake. That will result in a defect. What is a defect? A flaw in the system, flaw in a component or a system. That will introduce a defect and that will make the system fail, which will actually deviate from its expected output, expected functionality. So this is the flow. Somebody does a mistake, results in a defect, will actually result in the failure of the system. So are these definitions clear? But just not the always testing is enough, right? So if to do that, not always testing is enough. So that's why there is something audit also happens. So executing the tests help you to move forward and improve the quality of the product and service, but that's one type of verification or validation. We actually call testing is actually, I'll introduce these. There is something called verification and validation. So it's more of a validation, but it also requires some kind of an audit. Okay, so let's talk about what is verification and validation. In fact, I don't know how many of you actually know the difference between, I think it's worth to talk, the difference between QA and QC, quality assurance and quality control. A lot of people will say I'm a QA engineer, right? Or you say we are working in QA department. Quality assurance, QA. The other one is quality control. Quality control. So as a tester, where do you think you'll work? Is it QA or QC? Which department you are going to work? Sham is saying QA. Geeta is saying QA. Anybody has a different perspective? Are we going to work in QA or QC? Okay, Mukta is saying QC. But if I go with a lot of people are saying QA, right? Okay, let's park this question for a few minutes and then we'll come back and see where does it fit in. Let me explain what are these two. And in every department, be it software, be it electronics, electrical, mechanical, everywhere you will find these two, QA and QC. Both you will be there. Okay, what is a QA team? Basically, they are responsible for defining the process. Defining the process for the company. Whether you should follow waterfall model or you should follow agile model or you have to follow a combination of this, or is it an extreme programming, or is it an agile scrum you have to follow, what you should actually follow for your product, and what kind of requirement analysis you have to do, what kind of design you have to do, what kind of coding development activities you have to do, what kind of testing you have to do, will be defined by this team QA. So typically in every organization, this is like this. In every project, you will see dev team, test team, and PM. Of course, support team, who will support your environments and everything. Like this, you will find 4 different departments in every project. Project 1. Same thing will be there in project 2. Dev team, test team, PM, support. But this QA team works at organizational level. They don't work at the project level. They work at the organizational level to the company level, and they define the process to be followed by the company. For example, if a company wants to go for a CMM level certification, so these are the people who will define the process and what should be followed so that we can get a certification. And they come and do the audits, whether every project is really following it or not. They do a monthly audit, quarterly audit, half-yearly audit, yearly audit, so that they are good for when the external audit comes from the certification, they will provide all the required information. So this is more of a process people. And they are the highest paid people in the industry. Nor developer, designer, nobody can get that salary. Highest paid in the industry. And how many people we need for an organization? Hardly 3-4 people. And they come, define the process, for 2-3 years they work, ensure that the company gets a certification, and they'll move to another company, again start defining the process. Some companies will continue to use their services lifelong. So that is one, defining the process. No, BA is a different. BA is a business analyst. Like Mukta has a question, is a BA and QA are same? No, business analyst is a different. What is business analyst role is, he will try to get the business from different customers. He'll go talk to clients, customers, explain about the company, explain about the product, either try to sell it or get a new project. And then he will document it in something called BRS, business requirement specification. QA is different. Okay, now what is our job? Okay, when I say our, indirectly I'm assuming testing. So what is our job? We are responsible for basically following the process. We are responsible for follow process. Whatever the QA team defines in terms of how do you write a test plan, how do you write a test strategy, what is the test case format you have to use, all that, it's typically we follow what is defined by QA people. Okay, Shamsundar is saying for you, BA will do a requirement gathering, sales will get the business. Yeah, as I explained. Okay, another important point that we can talk about QA is they are responsible for prevention of the defects. We can say they are responsible for prevention of defects. What is that? Before defects occur in the system, how can we prevent? So that is their main agenda. Today we are building this system and there are highly chances every system will have defects. So how can we prevent them without occurring? So if we have a good process, if we have a good mechanism in the system, we can prevent it. So that is their primary motto. Whereas we are responsible for identification of defects. We are responsible for identification of defects. Now that you understood the terminology of defects, so I'm using it. We are responsible for the identification of defects. How much ever care you take, how much ever prevention mechanism you take, there are still chances defects might be there. Identifying those defects is our responsibility, QC responsibility. If I go back to the first point, the defined process, and we are saying we have to follow. Not only you, designer, developer, everybody should follow. What is a guarantee that you are following or not? So what they do, they come and does the audit. So they are responsible for internal audits. They are responsible for internal audits. Every month they will come to your project. They'll pick up the project manager, dev lead and test lead and ask questions. Hey, as per the process, you are supposed to use let's say ALM as the test management tool. So are you using the ALM management tool? If yes, can you quickly walk you through us where you are using it? And as per the process, you have to use a test case format. This is the format. Can you show me what is the test case format that you are using? Or what is the test plan template that you are using? So they'll ask you all such kind of questions. And they will believe only with the proofs. So you cannot just say, yeah, we are following. No. The problem is it's all internal audit right now. When they gather the information from every project like this P1, P2, P3, when they gather all the information, they will roll up that information to the organization and then they'll say, now every project is following, I think we are good for the external audit. So they'll go apply for external audit. And when the actually auditors come from the external ISO, CMM, Six Sigma, whatever it is, you should be ready for that. And which projects the external audits are going to pick up, we don't know. So that's why they'll make every organization, every project to be ready. So they are also responsible for these internal audits. What is our job? You have to simply support the audits. Whenever they come, provide the information. So you need to support the audit. So in a way, they work on a major principle called verification. They'll come and verify everything, whether you are following or not following, kind of thing. But testing team, what it does is, majorly what we do is validation. So because we need to understand this, we came here. Validation. What is validation? Suppose when a software I give it to you and ask you to test it, you will install that software and you will run the software. You will run each and every case and then see whether it is working or not. That is called validation. But verification is not that. Verification is like, suppose if I give you a design document and ask you to review it. So you will simply go through page by page, you review, you give your comments. Similarly, if I give you a user story or a requirement and ask you to review, you'll go through page by page, review it and give your comments. So that is called verification. So verification is like a static kind of thing. Validation is like dynamic. You will have to install the software and test it. Actually speaking, testing team does both. We as a testing team, we do both. We do verification, we do validation. If you're wondering how that is possible, just go back to my previous explanation. I told you first requirements, then design, then coding, then testing. Testing team will never involve directly in testing phase only. In today's world, testers are involved from the day one, that is from the requirements. Okay, what is your job in the requirements phase? When the requirements document is ready or user story is ready, you will go through it. You will ask questions. You try to get if there are any things that you have not understood. You review it and you give your comments. So what you're actually doing there is a verification. Same case during the design phase. When the design is ready, they'll give it to you as a testing team. You go through the design. You can give your comments. You can ask questions. So what you're actually doing is again a verification. But after coding is completed, what you do is actually called validation. So that's the way I would say a testing team does both. But at high level, what is our responsibility is validation, not just verification. Okay, if you still don't understand what is verification, it's like this. You can read out this question. Are we building the product right? So just try to understand this question, what it is. Are we building the product right? Validation is something like, are we building right product? Is there any difference in the question? Are we building right product? Is there any difference in the question? Are we building the product right? Are we building the right product? There's a lot of difference, right? First one is totally focusing on whether it is right or wrong. Are we doing it correctly or wrong? So that is totally about process. Yes. The second one, are we building the right product? The focus is totally on the product here. Whether are we testing the product correctly, building the product correctly. If the product has any issues, then we are responsible for it. So you're totally focusing on product. Here you're totally focusing on process. Correct. So that is a major difference between QA and QC. So they are responsible for verification, we are responsible for validation. Now tell me, where does you think testing fits? QC, right? But a lot of people, it's not just your mistake, but a lot of people, including me in the beginning, I used to call myself as a QA engineer. and everybody does that, so there's nothing wrong. Industry takes it very lightly. Both of them are same, but actually there's a difference. Everybody will say I'm a QA engineer, I'm a QA manager, I'm a QA lead. So that's why when you see a job requirement, right, job posting, you have to go through definition, what they're actually looking for. If they say we are looking for 3 to 4 years of experience who has an implementation of process for CMM, ISO, blah, 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 that is like a QA job. If they say we are looking for a QA engineer with 3 to 4 years of experience in manual testing, automation testing, black box testing, that's a testing job. So quality control is basically testing, but a lot of people say QA. Okay, so why I had to come and explain all this is for two good reasons. One is to understand verification validation, and one is to understand what is audit. Of course, to understand the basic difference between QA QC. Is everybody clear with the explanation that we have done, or anybody disagree, agree, or anybody has any other perspectives? Second point of QA, basically prevention of defects. What does that mean is, it's like this. Let's say before a disease attacks a human body, we take a lot of preventive care, right? For example, I don't know whether the season is good. Let's say a season in a flu. We know we are expecting flu is going to spread, so you take a lot of preventive mechanisms, right? So that's what is process. Similarly, before a software gets developed, what is the best process we have to follow so that we don't end up in issues? Okay, to give you some examples, they will define the prevention of the defects mechanism by following, coming up with a lot of checklists. They say when you're done with the requirement phase, when you can actually say you're done. So they say you have to follow these checklists. You have to have requirements completely captured. It is being reviewed internally by everybody, all the comments addressed, forward it to your client, take opinion from the client, address all the client issues, then you can say you're done. You cannot just say documenting done. Okay, now that you understood the flow from error to defect to failure, so Shyam is suggesting I should say prevention of errors. Yeah. As long as you understand the context, yeah, I think you're right. But is that meaning of prevention is clear now? But in spite of taking so many prevention things, there can be still some issues. Addressing, identifying those issues. You cannot release a software as it is to the market. You have to identify all those issues. So that is a QC job. So how many got impacted with the flu, diagnose it and identify is the diagnosis job. So that's what we have to do. Okay. Is it clear, Mukta? You asked that question. Okay. Now, when do defects arise? Okay, we understood. Somebody does a mistake that will result in a defect, will result in a system failure. But who will actually introduce and where it can be possible? If you see the first flow, requirements are correct, design is perfect, development is perfect, then product works as expected. So nobody has done a mistake here. Everybody has done their job very well. Requirement gathering was perfect, review was perfect, everything was perfect. They went to design was absolutely fine. We reviewed with the client said go ahead, we developed the system, developers are developed with extra care, testing team could not find any bugs, product is working as expected. That's the first flow. If you look at the second flow, requirements were perfectly alright, design was perfectly alright, but while developing the system, developer did a mistake. Developer introduced some errors. That resulted in defects and made the system failure. Testing team found them and the system is not working as expected. So developers introduced mistakes and resulted in the system failure. But it's not always developers. If you look at the third flow, PM did an excellent job, requirements were captured properly, but the designing team did a mistake. They did not understand the requirements correctly and they designed it in a wrong way. And this design is approved by everybody, so developers went and built according to that, testers tested according to that, and finally system is failed. The reason because the design itself went wrong. Do you see some kind of problems like when somebody is constructing a big apartment of a building or a building, there can be some one or two design flaws, and because of that they have to simply compromise and live in that particular flat or a building? Can be possible, right? Because based on the design only the developer will do it, and based on that only we'll test it. So the actual problem is made during the design. Sometimes requirements itself will be wrong. While capturing the requirements itself, your PM did a bad job. Now requirements are wrong, design will be obviously wrong, coding will go according to that, and that will also not meet expectations of customer. Testing also, because see, for both the developers and testers, requirement document is the base. Requirements and design is the base. So if you're just wondering how come that will happen is, requirements followed by design both will be given to developers and testers. So they develop according to that, we write our test cases and everything according to that, and you go test it. So if there is a mistake here, obviously they will develop accordingly, testing accordingly. What do you actually mean by design? Design is actually the design of the system. I told you, right? So high level design, low level design. Typically nowadays you see any project, it will have three layers. One is your presentation layer from where the customer will interact, a middle layer where the business logic will happen. Yes, it will be created by dev. Dev in the sense, some products there will be a designing team separately. They come from a dev background, but they exclusively become designing team. In some of the best products, you will find a separate design team. So let's say a presentation layer, and there is a middle layer, and there is a database layer. So even to get this level, the designing team will design, okay, we should have presentation layer to be used in XYZ technology, middle layer, let's say some, this may be WPF, just an example, presentation foundation, this is like communication foundation technology we use, and this is your SQL server. So they come up with this idea how we should define the system. And we cannot work with only one middle layer, so we need to have multiple middle layers, multiple database layers. So what should be the design of the system? You're right in a way. Once the design is proved, the dev team will come up with a technical specification, technical document, and test team will come up with a test plan. Okay, so the mistake can happen anywhere. It can happen at requirement level, it can happen at design level, sorry, it can happen at requirement level, design level, coding level, anywhere it can happen. But if you look at the cost, I'll just introduce to this. Let's say, suppose we are in development phase, and the developer is writing the code. He is also responsible for code review, as I said. He is also responsible for unit test. Suppose after writing the code, he is reviewing the code by himself. After that, he is doing a unit testing, and he found a problem. In his code review, or in his unit testing he found a defect. Now when he found a defect, the fixing cost, let's assume it's just X dollars, maybe some $10, or if he is billing as a $100 per hour engineer, let's say $100 will be the cost of the bug. Because what he'll do, he'll go back, he'll change the code, he'll again unit test it, okay, it's fixed, he's good. So the cost is like X dollars. But suppose in his code review he did not find it, so it's gone to testing team, and the testing team is actually testing, let's say. Now here is a testing team. The testing team is doing their job: integration testing, system testing, they're trying to do everything. Functional testing, load testing, performance testing, whatever they have planned, they are doing it. Load testing, etc. They found the defect, which developer could not find it in his testing. We found the defect. Now what happens when you found a defect? There will be a central repository, defect tracking tool. Defect tracking tool. So you go log there. I found this issue, yeah, something like ALM, something like Jira, you can think of anything. There are so many tools in the market. ALM from HP company, ALM from Microsoft is also there, Microsoft Test Manager. There is Bugzilla is also there. Jira is also there from Atlassian. Yeah, there are so many things. So anything, let's say your company is using, if there is nothing, you'll use an Excel sheet and you fill all the information. Nowadays nobody is doing, because there are freeware softwares you can use it. So you go log there, and then you inform the development team, hey, we found an issue, please look at it. Then development team will come here, they look at the issue, understand what you have logged, and they understand the issue now. They'll go code it so that it will be fixed. Then again they'll do code review, they do unit testing, they ensure this defect is resolved. Before actually making the code fix, they will also try to repro that. They do all that, and then they will give it to the testing team again. Hey, now it's not there, can you test it? So we will test it, we'll ensure the defect is fixed. So easily the cost would become $100, or I would say 100x, easily, because there's so much of flow now. You have to use a tool, this is a licensed tool, it's not free tool. Even if it is free, you have to log a bug, somebody has to look at, understand it, repro it, fix it, test it, then inform the testing team. So there is a workaround going on, there is a process going on. So that cost of the bug will become 100. That is still okay. That's what the companies want to do. Even if it is $100, we are fine. We wanted to identify and fix it. But what if testing team did not find it? So the next thing, it will go into UAT, user acceptance testing. It's called beta testing kind of thing in product. Now the users are actually testing it. When they do the testing, it's called user acceptance testing. When they do it, yeah, business team does it. Dev team could not find it, test team could not find it, but they found it. Something is not working. So then what they do, they will log a bug in the same tool. They will also have an access. Of course, they will prefix it with something like UAT, or their user's name will come. Then what we'll do, we'll immediately, testing team will get into panic and see, oh, what happened? Let's try to repro. So you will spend some time in reproing that. Then you are also getting it. Then you also update your escalation will happen. All those things are correct. Then you will go update it here with your comments. Yeah, we are also able to repro. Then development team will try to repro. Everybody will try to repro. Now development team also understood. Then they will fix it again, do the code review, do the unit testing very carefully, give it to testing team. Now the testing team does it very carefully, all the testing, and ensure the defect is resolved. Then they will notify, yeah, it's not there, can you test it? Now the UAT team does it and then say, yeah, it's not there, it's fixed, we're good. All this has happened. But cost, if you look at, I don't know, maybe 500, maybe 1000, it can easily go to any extent that. Because now you're involving actually users of the system, testing team, development team, to coordinate all these people, PM, everybody will involve now. This is in the worst case still okay, because the next phase after UAT is actually live, the production one. If none of these people did not find, development team did not find it, testing team did not find it, customers also did not find it, now it goes to live. Live is basically production. The real users are using it. Think of any of these websites, let's say online shopping application, and you open it for lakhs of people, millions of people, and millions of people have started using it. And there is a flaw in payments, for example, right? And everybody is getting the money back instead of paying it product, let's say, or everybody is able to see other people information who ordered what. Some kind of a bug you can think of. Huge loss of business, huge reputation to the company. I cannot really estimate how many dollars it will cost. It might completely break down the company itself. This company might have to shut down simply. Don't know. Depending on the issue. Nobody will come and visit this particular site in the future again, depending on it. So that is the cost of defect. And that's what we are trying to address here. Cost of fixing defects will, from requirements to design to build to test, it exponentially raises. I have taken only between dev and test, but before that, designing team does some job. Before that, PM does some job. So suppose if the defect got introduced here, and if it would have been fixed here, it would have been very less cost. But it's gone to design, gone to coding, gone to testing, gone to UAT, and users are found it. Then it's a lot of rework. So that's what we are trying to address here. Cost and time also. So over a period of time, if you find any requirements and if you find any bug in requirement and you fix it here and there, cost is very less. But if you find it during design, so you have to come back, change requirement, change design, cost will increase. It will exponentially increase as it goes towards a live. So that's what is all about cost of defects. Okay, then there is another question. Now we understood with yesterday's class, today's class, testing is very important. We don't want to leave, as a test engineer, we don't want to leave any bug into system. We wanted to ensure everything to be tested. So then how much amount of testing I should do? When can I really say, okay, I'm done everything and I'm confident to sign off? Again, that's a very difficult answer. You cannot do an exhaustive testing. You can never say I'm done with the testing. Because even after doing everything, there might be still something that you might have not checked. So it's very difficult. It's a very difficult job for us to take a call or a sign off. So that's why you have to balance it out between the risk of the system, complexity of the system. For example, if I give you a job to test automatic flight control system, on the other side, if I give you a simple video gaming system, so which one is more greater probability of failure and which one you have to focus on it? Which one you think you have to spend more time in testing it? Obviously the flight control system, because that's something that's the probability or complexity is very high and dealing with the real life of the people compared to a video game. The max, if a video game is failing, the kid will throw the game outside. That's what he'll do. But the first one is totally dealing with the real life of the people. So the amount of testing that you have to do, the amount of complexity lies in is very high in the first one. So that's how you have to balance it out. What we test and how much we test must be related to the risk, how much risk that particular scenario is. That's why when sometimes, yeah, prioritization comes, as Sham is saying correctly, we have to prioritize it. So even though you write 1,000 test cases for a product, not all 1,000 test cases are same important. There could be 100 very high priority test cases followed by 400 second priority test cases followed by another 400 priority 3 test cases followed by some 100 priority 4 cases. So you have to prioritize. First you have to focus on high priority ones followed by medium priority ones followed by low priority ones. So that's how you have to do it, so that you can keep the software under control, quality. Okay. So again, when it comes to, if you have to give a definition to a quality software, right, when can you really say a software is of good quality? If it is meeting the time, if it is meeting the budget, and if it is meeting the customer requirement, is what we call a quality product. Suppose you are ensuring quality super, you are eliminating every issue in the system, but if you are not giving to the client on time, then that is also no use of it. Because if you're not giving it on time to the client, time is increased, thereby money also increased. And customer, for example, let's say you want to build something for an upcoming season sale. And if you build a system after the season, then what is the use of it? So it's not called a quality software. So quality software is something, it has to meet the timelines, money that is expected or estimated with the proper quality, with all the features that customer is looking for. So one role of testing is to ensure the key functional, non-functional requirements are examined before the system enters. Basically, before system identifies any defects and reporting to the development team. So you are responsible for both functional and non-functional. Only we can highlight this. As a test engineer, you're going to do both functional testing, non-functional testing. So what functional testing? Testing the functionality of the system. Suppose if it is a tax calculation system, whether I'm able to do the tax calculations properly or not. If it is a application, some app on a tablet or a Windows or a mobile, the expected functionality of that app is working or not. What is non-functional? Non-functional like security. Actually nowadays security is no more non-functional. Security is a default. It's functional now because security is very risk. Everything is internet based and everything is security prone risks. So nowadays security has become default testing. Previously it used to be a very special testing. Security used to be a very, very special testing, but it's a very default. You have to do compulsory security testing now. Otherwise we'll end up into a lot of issues. So when I say non-functional, load testing, how many users it can support, performance of the system. So those kind of things, whether it is can be supported by these different browsers, browser compatibility. Okay, Sham is asking what is security testing. Can anybody would like to give an example? Ensuring that only authenticated people are accessing the system. Ensuring that, for example, only authorized people are using the feature. Let's say in a company website, not everybody can go and look into the details of salaries of everybody, right? It's only an HR team job. So if you're part of the HR team, you will have an access. If you're not part of the HR team, you don't have an access. Authorization, basically authentication and authorization, minimum. On top of it, there are so many security things. For example, nowadays you are working through banking software. What is a guarantee that you are the one doing the transaction? So they are sending you a one-time password to your mobile. They are asking you what is there on your grid, on your debit card, credit card, grid numbers. They're doing all this. That is for the security sake, that you are actually doing the transaction. All that. Oh, there are a lot of things like security issues. There are a lot of things like SQL injection, cross-browser, cross-site scripting. There are different techniques. I think when we talk about static and dynamic testing in our course, I'll touch up more in detail there. Okay, testing cannot be directly remove defects. Okay, one thing that you have to understand, you are not going to remove defects. Only your job is to identify and report it. It is a developer's job for fixing, and you are not even enhancing the quality by, you can give suggestions, but if the time permits, they will fix it, otherwise they won't fix it. Okay, but you are not really responsible for removing the defects. So by reporting defects, it makes their removal possible and also contributes to the enhancement of the system. So when you actually reporting the issues, PM will take a call whether it needs to be fixed, not fixed, by talking to client, and if it needs to be fixed, they will remove, otherwise they'll push it to the next release. Systematic coverage of software products in testing allows at least some aspects of the quality. So again, if you go in a very systematic way, like first unit testing, then integration testing, then system testing, then end-to-end testing, followed by load testing, performance testing, browser compatibility testing, operating system compatibility testing, GUI testing, usability testing. There are so many different techniques in the testing world, about 30 to 35 we can easily say. Globalization, localization, regression testing, I would say usability testing, I already spoke. So like that, if you go in a very systematic way, you can identify all the issues in the software. So that's where the test plan plays a major role. So when I talk about test plan, I'll decide and I'll explain more. So testing is one component in the overall quality assurance activity that ensures system enters service without defects, otherwise it leads to serious failures. So we are there to eliminate all those issues in the system and to release the software with a proper quality into customer. So that is what is testing and quality is all about. Any questions so far? I think let's just stop after talking this point. So now that you understood testing is important, when we should stop? When we can say we are done with the testing? As I told you, it's very difficult to say this. And in the previous olden days, they used to stop when the time is over, when the budget is over. Even though there were issues, they used to stop. That is not the right way. So for example, if you have written 1000 test cases, ensure all 1000 test cases are executed at least once. At least once. And all the issues you reported have fixed. The defects that you have reported have fixed. And you have been regression tested, you have been retested them, the fix you have verified, it's working fine, and there are no more issues in the system, then you will actually say I'm done with my testing and it's good for release. So that's a good criteria. Okay, generally every company will have its own criteria. Typically in my case what we do is we do like this. Actually, not every defect is of same complexity. We categorize them as a severity. I'll talk about these levels in detail later, but people call it as 1, 2, 3, 4. Severity 1, 2, 3, 4. Severity 1 means it's high critical. So in my case, if there is any, not only in my case, in any product, if there is any one severity 1 defect also is there, you cannot release the product. It has to be 0. Only when 7s are all fixed, you have to release. 7 means it's like completely making the system down. Your product is crashing all the time. Save to also 0. Again, nobody will release a software when there are save to issues. Save to is also critical issues. Some people will release a software even when there are save 3 issues. In my case, we have a cap of 5, max 5. So we can release a software to the customer even if there are 5 save 3 issues. But we have to clearly communicate to the customer what are the issues there. Save 4 are very simple. Any number of bugs also fine in my case. But in some other companies it could be this also could be 0 and this could be maybe 5, just as an example. But in my case the product is very complex, so we are okay to release even if I have 5 and any number of save 4. Save 4 means very simple issues. This message needs to be left aligned, right aligned, or this text is not properly visible, so we need to increase the font, something like those are small issues. But again in save 4 also there are some things. For example, if there is a spelling mistake in company, there is a company name and there is a spelling mistake, you cannot release a software like that. It has to be fixed. Okay, so that's the criteria we generally follow. So we cannot test everything even if we wish to do. So we also know that every system is subject to risk, one kind of other kind, and then we have to take a level of risk call, how much we should do, how much we should not. So that's where the prioritization is important. Categorize P1, P2, P3, P4 cases and test at least P1, P2, P3. Most it should cover both functional and non-functional. You cannot just say only testing the functionality. You cannot say I'm good, I can release. But if the system performance is very slow, security problems are there, it is not working on other operating systems, not working on other browsers, then no point in releasing the software. So that's when you can decide when it is enough to test. Okay, so quick recap what you should do. We will be circulating these documents very soon by the next session. But recap is you should understand what are errors, defects and failure from today's session. When the software, what are the different causes for the software failure? You can give some reasons for it or consequences, what will happen, and the triangle of quality that I discussed, right? The time, budget, this one, how it is important. So these things you should be familiar from today's session. All right, any questions that you have it from today's one? I'll try to make it as much interesting as possible, but I told you it's an examination preparation, so we have to come back to the document, go through these points, then I'll try to give some generic examples from the industry perspective so that make it interesting, and we have to move ahead. So go with this for today. With this, I think the free sessions will be done today. Day 1 and day 2 we are done. From Monday, we'll be actually starting with day 3, which is like a paid session. So please take a call over the weekend, and then you should complete the process so that we can move smoothly. All right. From Monday, I'll ensure all these materials will be circulated to you. All right. Have a good weekend. See you on Monday.